Hello, everybody. Hi, good morning. Hi, Philip.
Not morning.
It's close enough. The coffee hasn't completely kicked in, so it's still morning. I'd like to welcome you all to session 2G, curriculum issues number 1. Everybody in the right place? Like the lost accountancy student who's in the wrong room altogether. So our first speaker, we're honored to have the top 3 paper in the curricular initiatives number 3, introducing Python Sneks. Did I do it right, or Snakes?
That's perfectly fine.
Okay.
That's correct. That's correct.
Thank you. An open source, instructionally designed introductory curriculum with action-based research. And I'd like to introduce you to Austin Bart from the University of Delaware, who will give a talk.
Can you guys hear me okay? Can anyone not hear me? I should really ask. Thank you. So I often go by Corey. I am indeed at University of Delaware. I want to thank my co-authors who could not be here, Ali, Michael, and Larry. Ali and Michael are both undergraduate students who have gone on to other things, and Larry is an instructional designer. We'll cover him in just a bit. They're all at Virginia Tech, which is where I did this work. I also want to thank a number of people involved in this project at varying levels, including my former department head, Cal Ribbons, my colleagues, Paniotis Apostelis, and John Linskovich, and the many fine folks at Telos who gave me an awful lot of money to do all of this, which was nice. I like that. Throughout this presentation, there's a URL at the bottom, and I tried to make it visible, but I doubt it's going to be super convenient for those in the back. It's shown here at the bottom on this slide, and the next one near the end. This is everything that I have to offer to you. Everything that I've tried to make in such a way that I can share it with you. Some of it's a little bit secretive, and you have to come ask me via other channels, but for the most part, I'm trying to make all of my materials open source. That includes the slides and a lot of the associated materials with it too. So if you miss something, you come in late, you can go check that out and get it from there. Just to give you a quick overview of what I'm going to be talking about, I'm going to start with some of the motivating context and try and convince you that there are some problems to solve here. Then I'm going to talk about my experience in solving those problems, curriculum design type issues, and the specific things that I have done and created. Then I'm going to talk about what I think might benefit for you guys. Ideally, you should walk away with something you feel is a bit concrete. And again, all my materials and stuff are down there. Quick question. Who here has ever taken a course on, or is about or involved significantly with instructional design? There are so many people raising their hands, and it's outstanding. What a great thing. Every year I get to ask this question, I see more and more hands, and it makes me happy. It's a great subject. We'll talk about it in a bit. First, one more thing about me and who I am. My name is Corey Bart. I have a PhD in computer science and a learning sciences certification, so I try to live in 2 worlds, although yes, I probably live in one more than the other. This work started at Virginia Tech, as I said, but now I'm over at the University of Delaware. Hey, by the way, we're hiring. The associate level, in fact, so, if you're not entirely happy where you're at, maybe you want to talk to me a little bit. So, I don't know, you don't have to, just casual friends, right? It's continuing track teaching positions, although we also do a lot of research in interesting areas. Just to clarify further, I'm the one up above. That's me. My dog Ada is the one down below. She's fuzzier than me, although right now it's not quite the case. So I point out we're hiring not just because I'm trying to hire excellent candidates like yourselves, but because we all have a problem right now. Stop me if you've heard this before, but we have an enrollment capacity crisis. And we're not liable to solve it anytime soon, and in the meantime, we're kind of stuck with just a few set of not great choices. We could try and hire more instructors. Often they will not be necessarily up to the same standards that we've always had. Not necessarily a bad thing if those standards are too high. We can force ourselves and our colleagues to work more, teaching more classes and more sections and more students. We could teach worse classes. We could just accept from ourselves that we're going to teach courses that aren't quite as good. And some departments have elected to try and do all of the above. Hopefully, you're able to make some sacrifices and get some good compromises in there. Certainly don't let the deans see any of this stuff. Don't let them have any ideas. I won't necessarily say this was my direct experience, but as a first-year faculty at Virginia Tech last year, I spent 1 year as a visiting assistant professor. They asked me to redesign the Intro to Python for Engineers course. It's not what they call it, but it's more or less what it is. Usually this is a course taught by graduate students, adjuncts, who they got lying around it's not one of our core classes. It's a service course. And the department head said, hey, we should spend some time on this one. He got some money, he got a nice local grant to try and revise it. And he roped me into it because I'd been teaching another Python course and I had some experience. And he told me, you're going to have about 200, 300 students per section. My first thought was, wow, that's a lot of students. My second thought was, I should steal as much as humanly possible to make my job easier. So that's what I tried to go do. I would say I was disappointed. I felt like there wasn't really something that was exactly what I was looking for. I poured over a lot of existing curriculum. They were usually not quite the thing I wanted in the end. They were either too simple or too advanced. There were a number of courses I could find at various institutions that were public and open. SIGCSE papers that had been published about curriculum. They weren't always necessarily as open as I wanted them to be. There's, of course, the private courses and MOOCs out there, and very awesome interactive textbooks. I want to make clear that I have nothing but respect for Runestone, OpenDSA, CS for all these awesome, awesome interactive resources. But they're not courses, they are textbooks. They are, in some ways, different. And there's various emerging repositories of materials. CS Engage EDU was not the way it was a few years ago. It's really cool now. It might actually solve a lot more of my problems. But this is more or less a collection that I found. And if you want to look at it and make suggestions, please, there is a GitHub page tied to this list that you can go to, peruse with links, and make pull requests on. Because I know I didn't capture everything. I tried my best to find as much as I could, but I still didn't find everything, I'm sure. And usually when I did find things, it wasn't what I needed. You know, either, first of all, I was spending a lot of time just trying to figure out what the heck these things were, who they were meant for. It's usually a bundle of PowerPoint slides and a bunch of assignments without reference, without solutions, without instructor field notes or anything. And I was just kind of lost in all this. And honestly, the thing that I really, really wanted was a framework surrounding all of this stuff that could help guide me through this process. Because I want it to be easier for us to create and share and find and repackage and revise and adopt and make pull requests on curriculum resources. If that sounds like a cool thing to you, if being able to reuse material and share material, I would like to invite you to my Birds of a Feather tonight that I'm running with Phil Conrad, Michael Hilton, and Bob Edison, where we're going to try and make some progress on this, the problem of packaging curriculum materials. I will submit to you, and you are free to argue with me afterwards, that we haven't really solved this problem. And particularly, there is no well-packaged set of Python resources that I could use to go into a classroom and teach a bunch of engineers on the scale of 200, 300 very easily. So, when I was faced with this, and by the way, if anyone has epilepsy or anything, this next slide has an animated GIF. It's also very cringy, but I wanted to make the joke anyway. I decided, fine, I'll do it myself. So we had all this grant money, and I decided the goal would be, let's make a reusable, instructionally designed, open source, intro to Python curriculum for undergraduate teachers. And by the way, as I do this, maybe I'll learn something I can share with others about developing a process for doing all of those things. Well, this would have been a couple of years ago that we started. Today I bring to you that free Python curriculum, right? This is my URL. You can go there during the presentation, ignore the rest of my talk if you want to, and flip through the assignments and the quizzes and the slides and these field notes I wrote to myself, some of which are better than others. We'll get to that in a minute. Or if you want to keep paying attention, for now I'm going to talk more about how I built this curriculum, my experiences with it, and how I think you can go about doing these kind of things yourself. To try and get you an idea of what I did, of what I ended up with, a week of my course might look kind of different from what you're used to. If you go to my Canvas website, and you can, this is a publicly accessible thing, I have a fork of it that's public, you will see that it's broken into modules, and each module has a series of lessons. Lessons are meant to be short, little snippets of things. Ideally, in my head, half an hour per lesson. So here we have the module on making functions, returning printing, scope, documentation, functional decomposition, data flow, good things hopefully we all like more or less. Then if you click one of these links, you'll be taken to a page that has a link to a video. Well, not just a video, but also the transcript for that video and the PowerPoint slides that were used to produce it. There will also always be a quiz associated with that video. And I don't care if you watch that video or not, or if you read the slides or not. I care that you can pass that quiz. It's, going to be like 10 questions or so, plus or minus. Multiple choice, true, false, automatically assessed. You can take it multiple times. Mastery-based learning. Take it as many times as you want. And there'll usually be some programming problems too. And that's all done through a system I may call BlockPy. It's a whole other conversation for the conference, or maybe this one. But basically they're doing little exercises and they get automatically graded and they get feedback. You can do this with anyone's auto-grader. You don't have to pick mine. And then usually at the end of the module there's some kind of project. Usually not too long, usually not too messed up. The first one here, the second one is turtle art. So they've got to make a picture using turtles. And it has to be something that they are not afraid to put on their mother's fridge, or their parents' fridge, I should say. The fridge of a loved one is actually how I write it in the project write-up. And the projects obviously get harder as you go along. So that's sort of the model of what a week will look like in my course. You got 14 weeks over the course of a semester. The timeline of all this development started back in summer 2017. I worked in a workshop where they were helping guide us, and then I had my first deployment that fall. We had a second deployment in the spring. We made some changes. Last fall, I left Virginia Tech and handed the course off to someone else. We'll talk about that in a minute. And that's where we're at right now. So I want to call out particularly Larry Cox II, who is my instructional designer. I have training in instructional design. Larry has 10 times as much training in instructional design and was invaluable to work with during this process. Here's a tip, is go find an instructional designer friend at your university. Also get lots of money from your local Center for Teaching and Learning, if you can. That's also super convenient, because let me focus on this all summer. For those who are not familiar with instructional design, there's a lot of models out there. Some prefer something based on Agile, but here's a simple one. We begin with some kind of needs analysis and figure out what our learners need to do. We study our learners and our tasks, the things we're trying to teach them, and use that to develop our assessments, our exams, our projects, whatever you want to do that your students have to be able to complete by the end of the semester. You use that to develop a teaching strategy and to develop concrete materials afterwards. It's like software engineering. It really is. You don't start off by writing code. You gotta go write some unit tests. And you don't even start by writing unit tests. You go and gather user requirements. You go find out those scenarios. If you just start with the code, you're probably gonna mess things up. The advantage of this is you end up with some nice curricular alignment. Any other step on the end part here, you also evaluate the materials afterwards, ideally. Obviously, this is a chaotic design-based process. What I did has some reflection of this, but it's messy. I needed to begin off, and you would also begin off by establishing what needs you have. These can vary a lot. Are they cognitive? Do you have specific tasks, like knowledge, skill application kind of things that students will be able to do by the end of the semester? Should they be able to write a program? Or should they be able to create a website? Or solve particular difficult Python problems that you choose from a book? It could be motivational. I want my students to be satisfied at the end of the course. It's a non-majors course. They are not computer scientists. I would like them to be happy and not mad at the end of the experience. That sounds silly, but it's true. I want good attendance. Some people might say that. Some people might not care about attendance. It's something I value. And then I also want this to be easy for me to use and to share and to hand off. So you get all this stuff up front, and it influences the rest of your design. You figure out who your learners are through surveys, through analyzing your list of students and stuff. I did a lot of this stuff. This is what my students look like. They might not be like your students. That's okay. This is what influenced my design, and I ended up having essentially some personas in my head of what my students looked like and how I would cater my instruction to them. I also figured out what they were doing, and I ended up writing a really, really long list of learning objectives. I think something on the order of 100. It's listed in the paper, but who can remember such things? And these are at varying levels. So some of them are very basic, just create a simple program that solves problems using Python, all the way up to the level of being able to differentiate between vocabulary terms and be able to apply, write code that uses for loops or stuff like that. Learning how to write good learning objectives. Oh, I have the number right there, 234. Okay, that was a lot more than I remembered. Being able to write these things is actually pretty tricky, and it's a skill like anything else. There are ways to write bad learning objectives. You're not allowed to use the word understand, for instance, because you can't pry open your student's brain and see them understanding things. It has to be observable. It's a lot of little tactics like that a good instructional designer will help you with. From there, I made my assessments. I sat down and figured out what my exams would look like, what my project would look like. I say that I sat down and figured them out. A lot of this was on paper, being like, this is what it'll look like. And then I made it like, a week before the semester actually deployed those. That's just the nature of how my design process worked. But I had a good, clear vision of what they should be able to do by the end of the semester. And that allowed me to start laying out the actual content, figuring out what materials I would use, what kind of systems, Canvas, BlockPy, all these different tools, WebCat, Thonny Spider was my programming environment, although I use Thonny now. And I led to a particular layout of topics. You may fundamentally disagree with these topics, some of my colleagues do. That's perfectly fine. You can go teach your own version of this course. I'm presenting you the thing that I made. I also developed a lot of materials, and this is probably the thing that I am, most proud of. It's the thing that you'll find the most of on the GitHub, certainly. I have a lot of quiz questions. I have a lot of programming problems. I have a lot of video lessons. These things that I made are free and open. The answers are not free and open. The feedback code for the program exercise is not free and open. They're not open. Everything I do is free. I don't care about money. There's some amount of this being private versus public to the students. I want you guys to be able to get access to all of my answers and everything. I don't want your students to be able to Google for the answers. You may take these and modify them however you see fit, from my perspective. Just to go into a bit more detail about some of this, those quiz questions, multiple choice, true, false, those kind of things, I suggest having infinite tries. I administer them as Canvas quizzes, although I have a plain text representation in the repository. My programming problems, I use this style called misconception-driven feedback. I have a lot of Python code that analyzes the student's Python code to spit out messages that try and help them learn better. And that's all done through BlockPy, but you could really do it with anything nowadays, especially using our library called Pedal, which if you're interested in, check out the Virginia Tech booth and talk to Luke Busakuma, who's happy to tell you more. The other big thing was the video lessons. They are 2 to 4 minutes each. This is a flipped classroom kind of style. The PowerPoint slides are available to the students and to you. I have transcripts. I'm trying to write better transcripts that actually capture the content of the slides and not just the things I'm saying out loud. The videos have closed captioning. I'm very concerned with the accessibility of them and would like to do a better job with that. But there is, I don't know, that's somewhere between 100 to 200 minutes of video content for this course that you can all have access to. When you are handed something like this, I charge you all with demanding to know, does it work to some extent? And has the person thought about evaluation? What can they tell you about it? So I'd like to set a standard here for you to expect things from future presenters who try and bring you this kind of stuff. Evaluation can come in many forms when we talk about curriculum design. I use a lot of classical test theory in the paper to try and talk about item discrimination and difficulty. So in theory, you can look at a given quiz question and say, like, oh, this is a hard question because most students didn't solve it. Or it's a discriminatory question because it says, if you are good at this question, you probably did well at the rest of the exam, or not. There's ways to grade and evaluate the essay responses and find out if a question is too hard or too soft for the given audience. Collecting survey data, which I did a lot of, to try and get student perspectives. I collected too much of it. Every 2 weeks I had a survey that was fairly long. One of the feedback was too many surveys. And I also talked to my staff a lot. I had an army of TAs, and I made them write bi-weekly reports and sit around in sessions afterwards and describe to me how things are going. And I tried to get actionable items I could work on, so that afterwards I could come through and find out things like, oh, students stopped working on these programming problems because I assigned a project, and they were obsessed with that during that time period. Or I had too many easy questions in my work, and it's okay to toughen up the course a little bit. I ended up, we'll talk about that in just a minute. Got to start moving a little bit faster, I think. So for the fall 2018, when I was no longer at Virginia Tech, someone else had to pick up this course and teach it, John Wonskovich. Someone has already just made a pull request or some kind of issue on the GitHub repository. Thank you very much. Wow, okay. So these are some quotes I took from the guy who had to teach it after me. He felt very positive about the course, which I thought was really good. He gave me some concrete action items and said, like, these are things, it would be nice if it did this. And I try and be responsive. I don't teach at Virginia Tech anymore, so it's not necessarily my job, but I want to make sure this is really good. And there are errors, there are issues. And some of those he was in touch with me during the semester. Some of them I only found out when he emailed me on Wednesday with these quotes. But overall, he did say it was, kind of easier to pick this up and teach than if he had nothing. So that went well, at least. I had a process for making revisions, trying to organize things and collect things. I actually had a whole lot of principled attempts at trying to do some design-based research to improve the course. That's in the title as Action Design Research. I had a pair of undergraduate research assistants who did some really cool stuff. I promised myself I wouldn't talk too much about it during the presentation, and since I'm almost out of time, I will not. But on the field guide, there's a longer write-up of these experiments. If you want to tear into them, Mark Guzdial already has, so you can join him in finding things that are wrong with it. And make suggestions about the wording, which he also did, which was very helpful. This is not criticism, this was great. In retrospect, this was hard. Oh my god, I've worked so much in the past few years, I'm so tired. But it was worth it, and yeah, there's a lot of things to figure out, but I'm glad I did it. I want to propose to you that you all think about curriculum development along the same ways of reusable, packageable things you can share with others and evaluate and find out if you're doing a good job with. In the long term, let's stop remaking our CS1 course and our CS2 course and our awesome database course and so on. And if you enjoyed this stuff, please come to our curriculum materials packaging working group. And also think about Delaware as a place where you could potentially be hired and stuff. I'm trying to make more improvements on this. Maybe you want to work with me. I want to thank my co-authors and the many folks at Virginia Tech who made this possible once again. I also want to thank you because you've been a lovely audience. And once again, here are the links to all of my stuff and to the Curriculum Working Group's website. I'm out of time, I think.
Do we have any questions?
Sorry for talking too fast. Yeah.
Have you considered moving on to package this for like Computer Science A for high school level? There's a definite need.
That would be awesome. Can you give me lots of money and a lot more time?
I can tell you
Potentially
what I've
yes,
already
then
got.
yes, let's talk more.
I'm halfway there, but you have the expertise there.
And you know, I mean, like, this is already partially packaged. A lot of other people could do the same thing. This is not my project. This is everyone's project now. You're all responsible. Yeah.
How much additional time outside of what you would have done anyway would you say the packaging took? Because the
A lot more than I wanted it to.
Right.
There was not good processes for doing this. A lot of it was like, okay, I got to put this into a format that people can like use and accept, and it's accessible. It's like that doesn't exist. We're working on it, but it doesn't exist really. And it's like, what do I have to write? The field guide's incomplete. It's wildly incomplete. It stopped having good notes halfway through. And I got all these notes. They're over in my, in various places. I got to coordinate them. It's a lot of work. It would be easier if we had better processes, though. There was huge places I could have saved myself time. I'm hopeful.
So I'm really excited that you made this so easy and accessible for us to use. If I go to it and I want to take pieces but not the whole thing, what's the piece that would most hurt your feeling if I left it out?
Good question.
Important to you.
What is most important to me?
Yeah.
The thing that I like the most?
Yeah.
I really like the art on Project. What would it be? It's the old Project 2, which was the Goblin banking thing, and there's a really weird function in it. But like, I wouldn't really be able to say, oh, it's not crazy. You're probably gonna look at it like, oh, this was a weird thing that Corey did. I think it's hilarious and awesome. You'll have to develop your own opinions on Projects 2. It's about data flow, and you'll see it's weird.
Grindlehook?
Grindlehook. It's the Grindlehook one. I love it. If you can figure out what the Python code does, I want to hear it from you, because you're smart.
One last question.
Now that you've done this for Python, I think it would be a lot easier if you were trying to do a similar thing for a different language.
No.
It would still be like
It would be easier. It depends a lot on the language to some extent, but honestly, the same process can be applied to any course, CS1 or above. Would it be easier with a different language? Wouldn't be easier or harder, unless we get better practices in place. Then it would necessarily probably be better and easier. Would I be particularly better at a different language? I don't know. I really love Python. I love teaching it. You can probably convince me to do JavaScript or Java, but there are other languages I will not touch.
All right, we'll thank our speaker for his time. I pronounced it wrong.
No, I'm sorry. It's. I don't know why I needed that.
Because it's hilarious.
Something. I had so little time, and I went with this weird little internet joke.